In this gem session, we'll show how to create chamfered frame system as a method for rapid prototyping or fabrication using laser cutters or CNC machinery. We're going to start by creating a geometry. We're going to use SketchUp for this example. I'm using SketchUp 7 and I'm going to use Collada format. So I've got a surface created here, and I created a twisted surface so you can see how it will actually be resolved when actually exported from SketchUp to Gem. We're going to start by exporting the selected geometry. I'm using Collada format, and in the options you can see that I'm using export only the selection set and triangulating all faces. I'm going to leave the name here untitled so I can find it quickly. Exporting that and moving to Gem and loading a mesh file. I'm going to use the Collada format here and simply navigate to the file I created and opening it in Gem. When we import from Collada, we need to set the metric unit, and in this case we're using meters, not inches, so we choose yes here. This will convert it properly. Collada formats are natively using inches, and that's why we have to select that. So we've got the geometry in. You can see that it's all triangulated. I'm going to use the weld using the quick access menu, using right click and selecting weld. And I'm going to go to the edit menu and purge all the unused points. So I'm cleaning up the file. Once this is done, you can see that all the points are now in selection, basically ready for selection. What I'm going to do here is clean up the file using the profiler tool. I'm going to select the first profile, which is made of 2 points. So pressing Control and click on the first point and Control click on the second point. And then in Plugins Profiler, I'm going to choose by targets. I can allow it to run through, so I don't need to decide on the number of profiles, or I know that it actually has 13 profiles. I can type that in as well. I'm going to just type Enter to skip to the next phase. It's an open surface, so I select No, and it's an open profile, so I select No again. And the surface is then profiled. You can see using the face map, you can see that it was sampled properly. You can see how twisted it is, and that's why we have all this triangulation in the visualization of this map. I'm going to introduce now some subdivisions, so we can basically use horizontal subdivisions like this. So we can define the geometry properly, and I'm going to use a bookmark here, so going to create a bookmark. You can choose Control B as well. So this is quickly marking if we want to change anything and go back to the initial step. Now we can use the offset to define an offset, let's say 0.1, it's 10 centimeters. Let's see the result. You can see that it's not welded properly, so we need to weld the geometry. And let's make it maybe slightly bigger, so I'm going to use 25 centimeters, 0.25 typed here, pressing offset, and we've got our offset created. So next step is to create the chamfered frames. We go to the components menu and we choose chamfer frames. Now we need to define the chamfering, and this is basically a distance from the node or the vertex of a face along the face edge. So I'm going to use, let's say, 0.1, which is 10 centimeters, and pressing Enter here will calculate my frames. Now, when I created that, there is an overlap here of 2 faces, because each frame contains its own set of faces. So here, effectively, we've got 2 faces, one on top of the other. If you want to separate that, we can go one step back by undoing this chamfering, and we're going to set an echo on both meshes with a fixed value, and I'm going to introduce a 1% echo just to break the system here. So I'm going to type 0.99 and then press enter. Now you'll notice that I've got tiny gaps created here, which will actually allow to separate the frames when we want to unfold them. Now I'm going to repeat the chamfering. I'm going to type here 0.1, getting the chamfer calculated properly. Now if we wanted to visualize that, we can assign an offset for the depth of the material. For example, let's use minus 0.01 1 centimeter offset. It goes inwards. Let's check that. We can visualize that with a cube component. We use the negative value, so I'm going to need to flip the normals to get it to show properly. Just render that quickly by populating the mesh, and you can see that we've got nice frames created with this tiny gap for separation. Now if I wanted to unfold that for shop drawings, I'm just going to save in File, Save Mesh As, choose the main mesh, and this is the chamfered mesh basically, so we can just give it a name. I'm going to use mymesh.obj, saving it. And I'm going to use Pepakura to generate the unfolding for me. So if I want to create shop drawings of the unfolded frames, so I can use laser cutters to generate that and then assemble that, it's going to be very easy to do that. I'm going to start Pepakura. We're using that software for quickly unfolding geometries. Just opening the file, so I'm navigating to mymesh.obj like this. So we can take this geometry, we can point for the directions and anything like that. So basically we've got a geometry here, and we can unfold that quickly. So I'm just going to use an automatic unfolding so you can see the result, but basically every frame is created. You can see the chamfer part and the main part itself. So you can basically use a laser cutter, get this thing out, and basically fold it and glue using this latch here. So it's very easy to create those and assemble it to formulate any given skin that could be twisted or any kind of form you want. So it's very easy to explore this type of forms this way. If you wanted to take the geometry back to SketchUp or to your CAD software, you just save it to File. I'm going to use Collada output here. Save it like this. I'm setting the output to meters as well, so it's calculating quickly, and we can go to load it in by importing the geometry, and we navigate to gem model DAE, which is the file we just created, and I'm going to open it in just like this. In the options, I don't need to validate, but if you do, you will get a message that you just need to allow it to load, and we can merge coplanar faces. So you'll see this validation process. It's now validating. It's not created by SketchUp or Google Earth, so we can just say yes, it will load it in properly. Don't have to worry about that. Now we get the result, and we can just right click on that, soften it out, coplanar as well, and we can visualize the result quickly. So you can see that we generated a very nice model, very fast, very easy, and we can further explore that geometry if we want to.